In this lesson, we are going to do an example relating to carbon dating. And carbon dating is something that is looking at a radioactive element of carbon-14, and it has this half-life. So we have something that is exponentially changing. So every fraction of every second of every day, it's losing carbons, or whatever the scientific meaning is behind it, which is actually right here. So this kind of talks through a little bit of the discovery of it and kind of how it works. But our situation is the radioactive element carbon-14 has a half-life of 5,750 years. The percentage of carbon-14 present in the remains of organic material can be used to determine the age of the organic matter. Archaeologists discovered that the linen wrapping from one of the Dead Sea Scrolls had lost 22.3% of the carbon-14 at the time it was found. So how old was the linen wrapping? And so this piece kind of just talks about a little bit of the story of how it was found. It's kind of fascinating. So we are talking about an exponential, and it's going to be exponential decay. It's not going to be an exponential growth. So there's something that's going to happen in our answer that hopefully makes sense about the exponential decay, and it should be about our rate. Our rate should be a negative if we're going to have decay going on. So we'll see if that happens on the math. So we are talking about a half-life. So for our rate of decay, we don't know. So we're trying to figure out what the rate of decay is. So our rate of decay is, we're going to use this equation. We're going to assume that we're starting with a 1, like 100% of the carbon, and it's going to turn into a half-life. So in past lessons, you've talked about something doubling. So you've had 1 turn into 2. Well, this time it's going to make half of it. So if you start with a 1, so for our PERT, we don't know the rate. We know the amount of time, 5750, and the amount of material is a half after 5750. So we're trying to use that information to help us figure out just the natural rate of decay for a carbon-14. Okay, they just didn't give it to us, but they gave us enough information for us to figure it out. Then we're going to use that rate to actually figure out how old the Dead Sea Scrolls are, if they still had this percent left, or if they've lost that percent. So we have an exponential. We're going to solve it. We're going to try to get the power out of there, and to do that, we're going to log both sides. And so I can put the 1, but I don't need it. So 5750R. And then we logged both sides. The reason we do that is so this exponent can come in front. So we have the natural log of 1/2 equaling 5750 R natural log of E. All right, and then the natural log of E is just a 1, so that'll go away. We can divide by 5750. And that gets our rate to be, and if you divide that out, logging something smaller than 1 is going to get you the negative. So if you plug that into the calculator, you're going to get a negative 0.0001,205. So I'm going to keep as much of this as I can. So we are looking at this equation. 0.0001,205 time. So that's perfect. So we got a negative rate, which kind of corresponds to the idea that in order for this to go down, we have to have a negative rate. That's going to be our decay, which is perfect. So now we have everything that we need. So this is our equation, this is our rate. We have everything that we need in order to figure out the age. So it does say that we have 22.3% of the carbon lost, which means we have 77.7% remaining. And that's what we want. So it's not how much we've lost on this, it's how much we have. So we need that in order to figure that out. So we're going to be setting our equation to 0.777 because it is a percentage. And we started with a 1, and we now have our rate of 0.0001,205 t. And then we're going to solve this equation. So it's going to be very, very similar to this. So we are going to log both sides, 0.777, equaling a negative point. We'll log both sides, e negative 0.000125t. We'll log both sides so this power can go down. So we have the natural log of 0.7777 equals negative 0.000125t, natural log of e. Natural log of e cleans itself up very nicely. And then we're going to divide both sides by this. Now you're dividing by a negative, but when you log something less than 1, it's also going to be a negative. So you're going to have a negative divided by a negative, which is good. And that'll give us a positive time. So we'll divide by that decimal, negative 0.000125. Let the calculator do the work. And we're going to get roughly 2093.1 years old. But that was years old when it was found. And it was found in 1947. So years old in 1947. So it depends on what the question that they're asking for, and I think this was how old was it at the time it was found. So at the time it was just over 2,000 years old. All right, and so that is doing a problem where we had an exponential decay going on because we had a carbon dating which had a half-life. So if you have a half-life, you'll always have a decay going on. We set our equation equal to a half, figured out what our rate was, and then used our rate to figure out our time. And the biggest thing is not setting it equal to the percent that's lost, but setting it equal to the percent that's still remaining. That's the key to making sure that you're okay on this problem. All right, and that was a carbon dating problem.